Hi, this video is about aggregates and how you can define your own aggregates in PGSQL for the PostgreSQL database. Okay, remember what aggregates are. They're basically a way of summarizing a set of values or a column of values into a single value. And classic example would be something like, let's say we've got a table of pairs like that. If I wanted to work out the sum of all the values in the X column, then I can do something like sum X from pairs, and that'll give me 20. Okay, so taking all of these values here and compressing them to a single value. Now if we look at something like sum of the y values, you can see that some of the y values are null, but sum handles that okay. It just adds up 3, 5, and 9 to give 17. If you replace sum by count, it only gives you 3 because there are only 3 non-null values. If you instead count the y values, you're going to get 5. Okay, but sometimes it's useful to count all the values regardless of whether they're null or not, and so I've defined a special aggregate to do that, which is like count, except unlike the count, the built-in count, it doesn't ignore null values, and it's called count all. So if there's no non-nulls, it behaves just the same as count and gives you 5. However, if there are nulls, it behaves differently to count. You see up here, count gives you 3. Down here, count all is going to give you 5. Okay, so there were 5 entries in the column, some of which happen to be null. Okay, so how do we define that? Well, in Postgres, the way that you define aggregates is you have to specify an accumulator. And the accumulator is a data structure that accumulates values as you work your way down the column. So think of it as iterating down a column and gradually, incrementally building up the single result value. Okay, so in this case the accumulator is a very simple one. We're just going to count the number of entries in the column. So the accumulator type is just an integer. With an aggregate, you also have to define the type of values that you're dealing with. So the values happen to be integers in the column that we're looking at. In fact, I could have made this a special data type any element, but I won't bother doing that here. Alright, the other thing you have to worry about with an aggregate is what is the initial state of the accumulator. In this case, we're doing a summation, so the initial state is the sum of 0, so that's 0. And the final thing that's essential for defining an aggregate is to define a function which gradually produces the final result. You can call it an increment function, but essentially what it's doing, it's taking the current state of the accumulator, it's taking the next value in the column, and then it's producing a new state of the accumulator based on the current value in the column. So we're defining that using the one more function, which you can see up here. So one more is a function that takes the accumulated value, and here I've used the PostgreSQL shorthand for integers. I could more properly define that as an integer. X represents the next value in the column, and the result, the integer result, is going to be the new value of the accumulator. Typically, the type of this and the type of this will be identical. Alright, so if we look at the body of the function, it's a PLPGSQL function enclosed in $. It's got a slightly weird format because I wanted to make the point, or wanted to do two things. One is to show an if then else. The other thing to show is to make it explicit how this is different to the built-in version of count. The built-in version of the count makes it check something like this, and if it is, then it doesn't increment the sum at all. It doesn't increment the count of the number of items. So in the built-in version of count, this value would be 0. But of course, what we normally want to do, every time we see a new X, every time we see a new item in the column, we want to indicate that by advancing the accumulator by one value. So this takes in the current count of the current number of values that we've seen so far in the column, takes the next value, and then returns the new count, which is always going to be one more than the current value. Okay, so that's how we implement the aggregate. So we have to define the, if you like, increment function, and in this case that's one more. The increment function takes an accumulator type, an item type, and returns an accumulator type. So in this case, both integer and integer. In fact, all of the types here are integers. I said that you could actually make this more generic. So at the moment, this will only count all values in a column of integers, but in fact, Postgres allows you to define, if you like, a polymorphic function, and you can have any kind of element in the column, and it will still count appropriately, and it won't ignore nulls like the current version, like the built-in version of count does. So that's pretty much for count all. That's a fairly simple aggregate. They don't come much simpler than that. So what I wanted to take a look at now is an aggregate that we can use with different data type, with strings, and it will take a bunch of strings, a column of string values, and concatenate them all separated by a pipe symbol. Now I'll show you what the intention is in defining things this way. Let's just do here. So what we want to do, we're going back to the pizza database, and what we want to do is produce a list of pizzas, and in each tuple we'll have the name of the pizza plus a list of all of the toppings. So the toppings are stored individually in the toppings table, and of course the has relationship table links the pizza to the whatever toppings are on that pizza. So potentially we'd get a list of pizza names. For each pizza name a topic, next pizza name a topic, next pizza name a topic, next pizza name a topping. Let me So I can show you what the sort of starting point for all of this is by actually taking that part, and I'll have to paste it into the pizza database and modify it a little bit. So this isn't going to work. Well, it might. It won't work. That's good, because I didn't have any group by function, but I didn't want a group by anyway. What I wanted was to simply list the name of pizzas and toppings. Okay, and hopefully the has tables in the right order, so I'll get something reasonably sensible out of that. So it happens to come out in the order of pizzas anyway. So here we can see that a tandoori chicken pizza has all of these toppings on it, but they're all in separate tuples in this particular version of the output. Then we've got surf and turf, group of surf and turf, pizza entries with all of the different toppings, and so on and so on. So if you remember what group by does, it effectively allows you to select a group and then do an aggregate on that group. You know, a typical thing might be, how many toppings does each pizza have? Well, we can do that pretty straightforwardly. We could say, get the name of the pizza and count the number of toppings. And we could do that by introducing a group by. So we're grouping by the pizza. So all of those groups that we saw in the previous example, we'll simply count the number of items in each of those groups. So let's quickly run that query. So we can see that Super Supreme has 11, Surf and Turf has 6, and so on and so on. Okay, so just quickly looking at that again. So what we've done is we've used an aggregate over a group where each entry in the group refers to the same pizza, and we've simply counted the number of toppings. What we actually want to do is we want to get it to concatenate all of the topic names and give a single entry for each pizza. And it turns out that we can do that by defining a new aggregate that will concatenate the topping names as follows. So if we run that query, we can see that Super Supreme, and it gets a bit messy because most pizzas have a lot of toppings, but Super Supreme has beef, and then bacon and pepperoni and Italian sausage and onion and so on. Let's just scroll down to the last couple of pizzas because there's a couple down there that are fairly short. So this one is a little bit easier to see what's going on. Barbecue beef has beef, mozzarella and barbecue sauce as its toppings. And down the bottom here we can see ham and cheese, surprise, surprise, has ham and one type of cheese. So that's what we want to achieve. So we're using a group by, we're using aggregate to put together the list of all the different ingredient names that we saw here into a single text string containing all of those names separated by a pipe symbol. And we're doing that for the group that corresponds to tandoori chicken. Okay, so that's an aggregate. That aggregate does in fact exist in Postgres. It's called string underscore ag, I think, or maybe ag underscore string. You can look it up in the documentation. But more importantly, what we'd like to do now is actually implement it ourselves. So let's take a look. So that's what I just showed you. We've got a list function that takes a list of text strings and glues them together, separated by the pipe symbol. Alright, so let's see how we can increment it. Clearly, one thing that we're going to have to do is for each item, we're going to have to accumulate a list of strings by appending each item to the list that we've accumulated so far and separating it by a pipe symbol. So here's text concatenation. So we take the string that we've got so far, we concatenate onto a single pipe symbol, and then we concatenate onto it the next item in the list. So this is a standard aggregate accumulator function. So the accumulator type is a string, and we gradually build that string up. So this is the string so far. This is the next topping, if you like, and the result we're going to get back is an updated version of the string, which has this appended onto this, separated by a pipe symbol. Now, of course, the very first time you call it, you don't want to put a pipe symbol in front, so we have a check. If this is the first call to the accumulator, then we simply return the item, but every subsequent item has to be separated from the previous one by a pipe symbol. Alright, so that's the accumulator function. And the comment at the top is not correct because it's actually doing that as the separator. Okay, so let's look at the definition of the aggregate. Now this drop shows up an interesting inconsistency that occurs in some PostgreSQL commands. Some things like views and functions you can use create or replace. Other kinds of objects don't have an equivalent. They don't have create or replace. What you have to do is use drop, explicitly drop the aggregate, but only if it currently exists. If you try to drop something that doesn't exist, you'll get an error, but if you put in only drop it if it exists, you won't. So this is the aggregate. So the aggregate is something that takes a sequence of text items and produces a text result. So the definition, as before, we have an accumulator type, which is, if you like, the list that we've built so far. We have an initial condition on that list or string where the string is empty, and then we use the append function, which we defined up here, to incrementally add new items into the string. So aggregates, a lot of definition of an aggregate rests on the definition of this accumulating function. Remember, standard form of this function is the type of the accumulator itself, the data type. In this case, it's a simple text string. The type of the items that are being accumulated, and this is always going to match up with this, because this function takes the existing state of the accumulator, takes the next item, and produces the new state of the accumulator. So that's it, a couple of simple examples of defining your own aggregates. The accumulator in both cases was a simple atomic type. The first case was an integer, the second case is a text string, as we see here, but there's no particular reason why it has to be like that. The accumulator can actually be more complex, and in fact you can add an additional function here to take the final result and then make some kind of transformation to that and make that the result of the overall aggregate. You can look up how to do that in the PostgreSQL documentation, but a typical scenario where you would do that is if you want your accumulator to consist of a collection of values and gradually modify each of the values in the accumulator, and eventually you want to extract just one of those values at the end to be the result value. So you'd use a finalizing function to do that. Okay, so that's it for the discussion of user-defined aggregates in PostgreSQL.